if my last lesson recorded correctly. In fact, I don't think it did. Okay, so yeah, I wanted to kind of go over this again and give you some more examples of what you guys might need to do when you're solving systems of equations. So we're going to solve systems of equations graphically, by substitution, and by elimination. But first things first, I want to make sure that you guys know how to solve systems by graphing. And so if you're at all rusty about graphing an equation of a line, you need to make sure that you get really good at that. So when you have two or more equations with the same variables, that's called a system of equations, okay? And the solution to the system of the equation is where the two lines intersect, okay? All right. Algebraically, it's where the point makes both equations true. Okay. Now there's three possible solutions to a system of equations. You can have intersecting lines, which is just a consistent dependent system. We don't really go too much into the vocabulary, but right here would be your system. You can have no solution, and that's when the lines are parallel, okay? Because as you probably know, parallel lines never intersect. And then you can have infinite many solutions, and that's when it's exactly the same line and it's just graphed right over itself. Okay, so the key is with this is to make sure every equation is in slope-intercept form, and then you graph each line and identify the solution. So remember that this B is your y-intercept, and then you use the M, which is your slope. You use rise over run to graph the rest of the line. Okay, so I'm going to show you an example or two, and hopefully you guys can use that. So here we have two lines. You have to graph each line independently. Okay, so first one we have for y is equal to x minus 8. I'm just going to go ahead and write it. Now, when I write this, you'll notice that I'm going to put a 1 in front of the x because that's to remind me that the slope is positive 1. Y equals negative 1 times x minus 8. Okay, so I start at the y-intercept at the point 0, 8, negative 8, right? So that's right here. And then I use my slope. That's a positive 1, I'm sorry, not negative, which is 1 over 1, right? So from each point, I go up 1 and over 1. So I go up 1 over 1, up 1 over 1, and I keep going. And what I'm going to want to do is to extend this line as far as I can, because you never know where the two lines are going to intersect. And if the slopes are different, they are definitely going to intersect at some point. Okay, so there's my first line. Now my next one is y is equal to negative 2x plus 1. I don't know what I'm doing here. Plus 1. So my y-intercept is the point 0, 1. So that's where I start. Okay, that's my starting point. And then I use my slope of negative 2 over 1. I always say that the slope is kind of like your GPS. So you go down 2 and over 1 each time. Now I want to make sure I'm going in the direction that I need to be going in, so that's towards the other line. So I'm in good shape here. So here's my point of intersection. Now, just graphing the lines is not enough. You have to show me where these two lines intersect, and you have to write that point down. So this is the points 1, 2, 3, and I believe that's negative 5. The point 3, negative 5. Okay, now remember, these are pretty easy because they're already in slope-intercept form. What happens if we don't have lines that are in slope-intercept form? And that's when we get to ones like this, okay? So this equation right here is, we have negative 3x plus y is equal to 8. Now, in order to put this into slope-intercept form, I need to get y by itself. And that's what I call solving for y. So I'm going to add 3x to both sides of the equation, and I get y is equal to a positive 3x plus 8. All right? My y-intercept is going to be the 0.08, which is right here, and my slope is 3 over 1. Now, normally I would go up 3 and over 1, but as you can see, that brings me off the graph. So I'm going to go ahead and go the opposite direction. Go down 3, 1, 2, 3, and to the left 1. Now, as you can see, I'm still maintaining a positive slope. So I'm going to continue that. Down 1, 2, 3, over 1, and keep going. 1, 2, 3. I think I went down too many times. 1, 2, 3, over 1. Yeah, it should be here. And then down 1, 2, 3, over 1. And I keep going. All right. Okay. Then I'm going to take this one right here, and I have negative x plus y is equal to negative 2. So I'm going to add x. So I get y is equal to 1x minus 2. So I start at the point negative 2, and I would go up 1 over 1. But if you notice, I'm going away from that line. So I want to go down 1 and over 1, down 1 and over 1, and down 1 and over 1. Okay, and there's going to be a point where I hit the line. All right, now I didn't graph these very well because it's very hard to do on this thing. So, but hopefully that gives you an idea of what you're trying to do. Also, a great resource for you is Desmos, and being able to plug that into the equation, because in all honesty, you do not even need to solve for y in order to do that on Desmos. So I will show you guys how to do that, but just not at this point. So hopefully that gives you guys an idea of what you need to do. Please let me know if there's any more examples that you want me to go over. And just to give you a quick, brief idea of graphing or solving systems by graphing. So hope this helps.